You guys hear that sound? That's the sound of us cracking open a brand new advent of code. Check it out. I got it. That was a can of soda. Anyway, welcome back. It's day 3. Let's dive right in. You know what this is about. If you watch part 1 and 2, you know I'm trying to do as many of these as possible before totally wrecking myself. So before I open this up, let's make sure that our environment is working. Hello goes here. I'm going to be writing Elm on the left, and I'm going to be seeing the output on the right, and we're going to build this program step by step. Let's see what we need to do for day 3. All right, day 3 lobby. You descend a short staircase, enter the surprisingly vast lobby, and are quickly cleared by the security checkpoint. When you get to the main elevators, however, you discover that each one has a red light above it. They're all offline. Sorry about that. The elf apologizes as she tinkers with the nearby control panel. Some kind of electrical surge seems to have fried them. I'll try to get to them soon. Or get them online soon. You explain you need to get further underground. There's a lot of exposition here. Well, you could at least take the escalator down to the printing department. Not that you'd get much further than that without the elevators working. That is, you could if the escalator weren't also offline. But don't worry, it's not fried, it just needs power. Maybe you can get it running while I keep working on the elevators. There are batteries nearby that can supply emergency power to the escalator for just such an occasion. The batteries are each labeled with their joltage rating, value from 1 to 9. You make a note of their joltage ratings, which is our puzzle input. Let's grab that, copy. The batteries are arranged into banks. Each line of digits in your input corresponds to a single bank of batteries. Within each bank, you need to turn on exactly 2 batteries. The joltage that the bank produces is equal to the number formed by the digits on the batteries you've turned on. For example, if you have a bank like 1, 2, 3, 4, 5, and you turn on batteries 2 and 4, the bank would produce 24 jolts. You'll need to find the largest possible joltage each bank can produce. In the example above, 98. You can make the largest joltage possible, 98, by turning on the first 2 batteries. This is 89. 89 jolts. Let me see if I can get ahead of this. This one looks like 78. Perfect. Yep, and then 92. Cool. The total output joltage is the sum of the maximum joltage from each bank. So in this example, the total output joltage is the sum of all those things, which is 357. All right, find the total output joltage. Cool. All right, so I've got this in my clipboard. We are going to paste that right in here and see what we've got. So here, all I've done is I've just trimmed the white space off the string, and then I'm using this to turn it into something I can render on the right side. What I want to do is I want to break this into lines. So after we trim it, let's break this into a list of strings. And then for each one of these, we want to calculate the joltage. So the joltage value, if you give me a string, it's going to give back an integer. So what I think we want to do is for each line, we're going to want to kind of start from left to right. We want to get the maximum value. And then second biggest value. I don't think we want every permutation necessarily. I think we just want to go through kind of the first list, get the biggest value. I think that's always the way to go. So for example here, we don't want to get the 8 because that's too far to the end. There couldn't be anything on the right of it. But I think what we want to do is basically find the index of the largest value in kind of the beginning of the list, not including the last number, and then use whatever is to the right of it and do the same thing. So find the maximum there. So the way I'm going to do this is I'm actually going to show you each transformation one at a time. So rather than annotate this and say I'm going to go all the way from string to int, I'm going to comment out this annotation, and we are just going to kind of transform each line piece by piece. So the first thing I want to do is say string.toList. This is going to give me a list of these characters. And so now every single list is broken, and it looks like I perfectly, the size of this is, oh yeah, I guess there was some tolerance there. It wrapped really nicely, so I'm happy about that. But what I want to do next is I want to do a filter map and see if I can turn each character into an int. I don't think this function exists. It doesn't. Let's see what toCode does. toCode, maybe this is, so see this is 57. This is actually a 9, so I think I need to subtract a certain offset, probably 48. Okay, so all this did, I'm going to comment this out. This took the character from this, and it just got rid of all those quotes around it. So now these are numbers. And so I think this is working better. So if you look over here, this is now our lists, and I'm just going to resize it so it wraps nicely. So for each one of these, what I want to do is I want to basically drop the last character and get the index with the max value. There is a list extra package that we used in yesterday's video. And I think this is going to really come in handy. We can open up the docs here. I think drop. We can just use take to take the length minus 1. So we can say for each of these lists, this is going to be numbers. And I'm going to use Elm format to snap everything into place. Let's make sure everything's still the same. Looks like it is. What I want to do is I want to drop these last digits. So at least to calculate my everything but the last. Numbers without the last digit. And I'm going to annotate these. So this is a list of ints. Numbers without the last digit. That is also going to be a list of ints. It's just going to be a little bit smaller. So we're going to do list.take, list.length of numbers, minus 1 from numbers. So if I return this, hopefully what we're going to see is that this 1, this 9, this 8, and this 1 disappear. And it looks like they did because we're not seeing them anymore. And you saw that kind of the layout wrapped differently. That's because we dropped a digit. So here, this is where I want to get my max from. Max of first list. List.max. Numbers without digits. Okay, great. So what this is doing is this is giving me my initial digit in all these cases. So I'm going to bring this over here. So I had 98, 89, 78, and 92. So I should have 9, 8, 7, and 9 in this list. 9, 8, 7, 9. Perfect. What I want to do is I want to get the index of all these things. And maximum doesn't do that for me. What I want to, I could use list.extra to basically say like, hey, find this 9. I'm just going to do maybe default -1. This should never happen. But it's going to get rid of that just for me. The right way to do this in Elm is to kind of keep all this stuff as a maybe and return this whole thing as a maybe int, because you could give it an invalid line. You could give it, you know, like ABC. This function would do something crazy if you do that. So maybe I'll do 0 as the fallback. I think I can say index of first digit. So I'm going to just call this first digit. List.extra dot get index. Let's find out what that function is. Index. Element index. Okay, so this gives you a list. I just need the first one. So I'm going to say element index. It's going to give us the first occurrence, and that should work just the way that our algorithm works. So the element index of the first digit. So for this should say where in the original list. Oops, I didn't import stuff. Oh yeah, I got to give it the list. I can give it the original. It's going to be the same result either way because we're getting rid of stuff at the end. What this is saying is that the index here was 0, the index here was 0, and the index here was 13. And what's useful about this is I can say second list is going to be list.take, and you're going to take, I guess, list.drop. We're going to drop this much from the original list. And so if we look at what that value is, oh yeah, let me give a silly default. This one I'm going to default to the length of the numbers list. And I'm going to format this. And what this is going to do is drop all the things that come before it. So when I find the 9, I don't want to look for other digits in the full list. I just want to look from 8 through 7. So that's what this is here. And similarly, when I find the 7, I'm only allowed to look through what comes after 7. So I get this 8. So 9 and 2 is really what we want. Second digit is going to be the same exact thing. I'm just going to copy this whole thing, paste it, paste, paste. Cool. And I'm not returning that. But what I can do is I can say from it, first digit, smush that together, second digit, and now we're getting really close. Oh, sorry. Second list. Let me make these names a little bit clearer. This is the first list, which is also the numbers. That. But here we have our 98, our 89, our 78, and our 92. And so all I'm going to do is I'm going to say string dot to int. That should give me a maybe. And I can do a maybe with default here. I can also make this maybe behave correctly. What I'm going to do is I'm going to say this returns a maybe, and I'm going to use a filter map here. And that's going to give me my numbers. And yeah, I'm just going to sum those together. And so we get 357, and that is the answer for this. So what I'm going to do now is I'm going to come back over here, day 3, part 1. I'm going to hit save. So that's great. And all I'm going to do is copy this. Paste it here. Okay. So I just want to make sure that this is backed up. And I'm going to get my own puzzle input. So I'm going to take these really big numbers. And what I'm going to do is I'm going to plug in all that stuff. And I get 17092. Let's see if that works. Awesome. Okay, that's great. We got part 1. Let's see what part 2 is and if we're going to need to refactor anything. All right, the escalator doesn't move. The elf explains that it probably needs more joltage to overcome the static friction of the system and hits the big red joltage limit safety override button. You lose count of the number of times she needs to confirm, yes, I'm sure, and decorate the lobby a bit while you wait. Now you need to make the largest joltage by turning on exactly 12 batteries within each bank. The joltage output for the bank is still the number formed by the digits of the batteries you've turned on. The only difference is now there will be 12 digits in each bank's joltage output instead of 2. Got it. Okay, so we want to repeat that process for all of these. And what I was doing is I was manually kind of doing that, but I think we just need to use a bit of recursion and we should be okay. Let's go back to where we were. So this one's going to be part 2. And what we want to do is we want to kind of do this first list, index of first digit, second list thing, and we want to keep going while our number is less than a certain amount. So I'm going to take all of the stuff that we did and just kind of have a number that goes down. And so this is going to be like the number of steps. And it kind of makes me want to just make this return an int, but I don't know. We'll see how this goes. I think here, we'll see. Okay, so steps, we're going to have the line, and we're going to return this. So all I'm going to do here for now is I'm just going to give it 12, pass in the line, and nothing should change here. This should still do the same thing. But we're going to want to make this a recursive thing. So really, this is the part that I want to make recursive. This is the part that I don't think needs to be recursive. This is just getting the numbers. So we're going to take these numbers in. This is going to be a list ints. And so I'm just kind of refactoring step by step here and hoping that at each step I don't break anything. So I'm just pulling out what I need to. I also think that the way that we're doing this can be thought of as a list. So list dot filter map. I guess list dot map string dot from int. And then I can say string dot join. I think this will still give me 357. Great. Okay, so all these changes I made aren't changing the behavior of the program. They're just reorganizing it so I can start extracting the code that I want to reuse and loop over in a nice way. So here I'm just returning a list and I'm bringing up the concatenation, that last step at the end. And so what I want to do here is I want to make this recursive. And so the way that it's going to be recursive is it's going to say, you know, like I've got some number, we'll call that steps, and we're going to start that at 2. And my goal is to make this spit out 357 when I'm done with this refactor, and then I'm going to bump it up to 12 and hopefully get the same answer. But the idea is I'm going to take the numbers. This is going to be the original list. Original. So I want to call it that real quick. Oops, original. Great. So what I want to do is I want to pass in this original list. And most of the time when I'm looping, I just want to kind of take whatever my index is that comes in. I almost want to extract this up here, to be honest. And then kind of loop with the index and just kind of loop this part over and over again. Let's see if that makes sense. So I'm just going to take all of this. This will kind of get my loop started. And then what I want to do is have this be like n minus 1. I'm just going to put n up here. So initially, we just wanted to take 2 digits. I'm just going to call this digit count. And this will be the number that we change. I'm just going to pull this out. And what I want to do is call this original. Pass in original. And I'm going to pass in the initial index. So this is going to be index. Oops. This dot append first digit. Let's see if this is correct. First digit. Oops, sorry, I'm doing this wrong here. Okay, so we're still in a good spot. This is going to be the recursive function here. So what I want to do is if the steps, right now the steps is at 1. I'm going to keep going until the steps is 0. So I'm going to say if steps is less than, or I guess if steps equals 0, less than or equal to 0, just to catch negatives. That's not going to happen with our algorithm, but we're going to do it. I'm going to call this the sublist. Last list. I don't think the original is what we're going to be thinking of. I think this is going to be right. So last time when it was 2, we did digit count minus 1. We did 1, right? When it was 2, it was 1. So I want to say 2 minus 1 to get this back to being 1. But I'm going to call this digit sublist. And then if I'm done, what I'm going to do is I'm going to say list so far. I'm just going to put this in the front. Order doesn't matter, so I'm just going to put this in the front. So when we're done, we're going to do the digits, the list so far. Initially, as we're looping, maybe that's where we'll put this. So we don't have to do this append. But if there are more steps to go, we are going to recurse. And so every time we recurse, we are going to decrement the steps. That's really important because that's going to help with our kind of like exit thing. Our index, sublist. I feel like sublist is all we need. I feel like this will be the new list. And index. No, we need to calculate the index each time, sorry. Index of digit. Last list. We get the stuff, we find the max digit, we get the index of it. So we want to know where is the index in my sublist of the digit. And by default, this doesn't matter. This should always return something. So just to simplify it, I'm going to keep that at 0, and I'm going to make this 0 too. This shouldn't matter. But what I'm going to do is I'm going to say this new list, or new list so far. It's this, boom, boom. What I don't like about this is I feel like this is the part I wanted to reuse. Here's where I'm headed. So before I was like, let's say we're selecting 2. So we were initially selecting 2. What I was doing is I was saying you can only do this because I need to have at least 2 digits after. What I'm afraid about the way I'm doing it is, for this example, if I say select the biggest number in this list, it's going to give me 8. And then it's going to say, okay, now give me the biggest number in this list. If it grabs 9, that's not good. We don't want it to grab 9 if it's more than 2, because there's no room after this. So I think just like we did this, I think that's what we want to do here. And so this makes me feel like the remaining steps minus 1 is what we want. So rather than dropping a certain amount, I feel like I've thoroughly confused myself. I've changed too much here. I might need to rewind. But we're getting close. Let's see if the compiler can help me out here. Okay, 330. So what I want to do, this is wrong. What I'm going to do is see what digit I'm finding here for each list. Oh yeah, and I'm gonna get rid of this. I'm gonna get rid of all of this because I think we're doing this now. So we're gonna pass in the digit count. This is gonna start at 2. We're gonna start with an empty list. Digit count. So this is gonna be like the number of digits remaining. So I'm gonna call this remaining. I don't know if we need an index yet. I'm gonna get rid of it. We're gonna keep index. Okay, so we're gonna say the last thing was basically not found. This is whatever. This is my original list. I think we're gonna be able to make this work. So we're gonna take digit count. That's gonna come in as 2. Remaining. So the first time this comes through, it's gonna take the length of my list. That's gonna be an integer. So the first time this comes through, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think for this there's an easier way to do this. I just have to look at 2 numbers, but actually that's not true. It could be this and this. Never mind. Okay. So I'm going to take the length of the list. And so if the length of the list, let's say, is 5, let's just use examples. So let's say that my list is 1, 2, 3, 4, 5. When I call this the first time, I'm going to say I have 2 remaining. Index is 0. This might be silly. And my list so far is empty. And my last list is 1, 2, 3, 4, 5. I'm just going to type my lists like this. It's not really a list. I just don't want to type out all the commas while I'm thinking. So length is going to equal 5 because that's the length of this list. The sublist that I'm interested in looking through should be 1, 2, 3, 4. So what I want to do is take the length 5, subtract 2 from that, subtract 1 from that. Does that sound right? Subtract, take 5, minus 2, minus 1. 5 minus 1. This is what I want. And what this is going to do is this value is going to give me 4. And so it's only going to take the first 4, and that's what I want here. So I'm going to find the maximum digit there. That's going to be 4. And I think that's good. I'll take 4. So the digit will equal 4. Index will equal 0, 1, 2, 3. I don't think the index is going to come into play. I think we're going to take care of that on the outside. So index doesn't matter. Index the digit, and then new list. I'm going to call this digits found. I'm just going to call this digits. And I'm going to call this, yeah, last list is okay. Okay, so the new last list is going to be the list dot drop index of digit +1 from the last list. And then the new digits, I'm just going to append it to the end. It's going to help me debug this. It's going to be the existing digits plus the new digit that I just found. So here, this is going to be the new list of ints, the new digits. It's going to be another list of ints. And if steps is less than or equal to 0, that might need to be is less than, yeah, this might work. But I need something that'll return. Hopefully this is the right thing. Numbers 2 loops through, it'll be 1, loops through. I think if that's 1, then I'm done. Wait, 2. Yeah, I think that's right. That'll be new digits. And now this is a lot easier. I decrease the steps. I've got new digits. And I got my new last list. And then it doesn't know what steps are. So there's 1 remaining, just return it. And then list.sum, I'm going to take this out. So hopefully I get my original 98, 89, 78, 92. And the reason that I'm excited about this, okay, 1, that seems to work. Let's try 3. 987. What I'm going to do is turn these into numbers. So this said 987 is the biggest I can get. That seems right. 819 seems the biggest I can get here. 4, yeah, because 7 and 8. Because the biggest digit when you drop these is 4. So I think that's right. And then 889 should be the other one. Or 921. Oh, totally. 921. Great. So I'm going to bump this up to that. I'm going to sum those. Let's see if that was what we expected. 312191. Okay, that looks good. All right, so that was part 2. Let me add back in my annotations here. It always helps with recursion to just think of an example, at least for me. So definitely use that strategy. Elm doesn't have for loops, so a lot of the times I don't find myself having to write recursion, but I'll usually have like a fold or something like that. And so be sure to use this if you get stuck. I'm just a normal person. I can't keep everything in my head. As much as I post Elm YouTube videos, I run into stuff like that all the time. So it's really cool though that our solution for part 1 and part 2 is just change that number the way we have it modeled. So I'm going to save this. I am going to duplicate this tab just in case when I run this, I have any trouble with the larger input. I don't think I will. I don't think our algorithm's doing anything too crazy, but we'll see. It is a lot of lists, but I don't think it's going to scale out of control. Perfect. That was really instant. So let's see how it goes. That's 2 stars. Pretty sick. Okay, that was a fun one. I'll definitely share the template that I used, and then these 2 solutions in the bottom. Really cool. The part 2 was just, we got to just change a number. So I could pretty much just share the 1 and then you can change the 2 to a 12. But that's today's video. Hope to be back tomorrow. Today felt like a nice easy one. Wasn't too much crazy refactoring. We got to do a bit of recursion, but we'll see what day 4 has. I'll see you then. Bye.